Dear friends, the next dye is anthraquinone dye, and the name itself suggests that there is a presence of anthraquinone ring in the dye. And this dye is nothing but the hydroxy or amino derivative of anthraquinone. It is the derivative compound of anthraquinone. Anthraquinone. So, what are the derivative? Amino or hydroxy derivative. That means the amino or hydroxy derivative of anthraquinone called as anthraquinone dye. The compound in which amino or hydroxy group present on anthraquinone ring called as anthraquinone dye, or the derivative compound of which derivative? The amino or hydroxy derivative compound of anthraquinone called as anthraquinone dye. And this dye containing, what you can see here, it is a paraquinoid. This dye containing paraquinoid ring as a chromophore. And as I am telling you that amino or hydroxy derivative, that means amino or hydroxy group as a oxochrome. Right? So let you look at the most popular example of this category of dye is alizarin. Alizarin is the most important example of this category of dye. And let you look at the structure of alizarin dye. Here you can see anthraquinone ring in which paraquinoid ring is, this is chromophore, and this phenolic OH group, these are the oxochrome, and it imparts a red color to the fabric. It imparts red color to the fabric because it produces red color salt having melting point 290 degree Celsius. Now this alizarin is obtained from the roots of the madder plant. It is obtained from the roots of the madder plant. It was obtained from the roots of the madder plant, and because of the scarcity or less abundance, it is now and then prepared in the laboratory also. It is produced commercially as a synthetic product, so you can say that it is a synthetic dye because it is prepared in the laboratory as well. Now let me discuss the laboratory method of synthesis of alizarin or laboratory preparation of alizarin. The preparation of alizarin involves 3 steps. And let you see one by one. The very first step is the preparation of anthraquinone. And how do we prepare anthraquinone? When a phthalic anhydride treated with benzene in presence of AlCl3. This is the most popular reaction, most famous reaction as far as the organic synthetic chemistry is concerned. It is Friedel-Crafts acylation reaction, presence of introducing acetyl group on benzene ring. No, so whenever we have to introduce acetyl group on benzene ring, the most popular reaction comes to in our mind. The very first reaction is Friedel-Crafts acylation. So this is phthalic anhydride when reacts with the benzene in presence of Lewis acid AlCl3, it leads to formation of benzoic acid. Benzoic acid. And here the Lewis acid plays its role. The lone pair on oxygen accommodate in the vacant orbital. As a result of that, there is a formation of carbocation, and then it leads to one on hitting. It produces this compound, isn't it? So, what is the name of this compound? O benzoic acid. This is the state. No, actually, O benzoic acid, which on acidification with concentrated sulfuric acid leads to formation of anthraquinone, because there is elimination of water molecule H from here and OH from here. There is elimination of water molecule and leads to formation of anthraquinone ring or anthraquinone unit. This C double bond O, as it is here, it is formation of C double bond O, and this is the anthraquinone ring. Now the second step is the sulfonation of this anthraquinone. Second step. This anthraquinone, on treating with the concentrated sulfuric acid, undergoes sulfonation, leads to formation of fuming sulfuric acid at 160 degrees Celsius, leads to formation of 2-anthraquinone sulfonic acid. Here it is the position, here it is the electrophilic substitution reaction. Sulfonation is nothing but the electrophilic substitution reaction or not. So this is the position where sulfur trioxide group is attacked, SO3. A sulfur trioxide, SO3, as an electrophile, it will attack at this second position, and you will get 2-anthraquinone sulfonic acid. Right? Now the third step is conversion of these 2-anthraquinone sulfonic acid into alizarin, means introducing OH group, hydroxy group here. Now the most popular reaction for introducing hydroxylic OH group on this intermediate compound is, we have to take a strong base or the base like sodium hydroxide. This is 2-anthraquinone sulfonic acid. We have to take a base like NaOH, where nucleophilic OH can attack at this position as well as this position. It is in presence of KClO3, and then followed by hydrolysis. First it is react with the base like NaOH in presence of KClO3, and then followed by hydrolysis of this compound. There is introduction of OH group at the position 1 and 2. So directly you can write, here it is alizarin compound. This is the quinonoid ring, paraquinonoid ring with the benzene ring as it is. Here it is one position with the OH and second position with the OH, and this is the alizarin dye, and which is ruby red in color. Now it imparts red color to the fabric, and in alkaline medium it imparts violet or purple color to the fabric, which is called alizarin. and it also used to give color to the cotton, wool and silk. So this is alizarin, one of the most important dye of anthraquinone type of dye.